Okay, Fourier series of even and odd function is a subtopic to help us to reduce our time to calculate. Just a few techniques, simple techniques to make us just skip a few calculations by using these properties. Okay, so we can see from the graph Fourier coefficient for the even function. So we know that there is symmetry in y-axis. So we can find the area under the graph is the same. So we just times 2 of the function. Okay, times 2. If that's why, but the difference between the previous one is this, and then we put 2 here as our double. We want to double the number of area. So from negative L to L, so we got only 0 to L. Also happen here, the same number, but we just double it. Okay, the even function has only cosine function term following Fourier series. So that is the most important one lah. So we know that once the cosine and sine, because in the previous function, general formula for the Fourier series, we have even and sine function. We have sine and cos function. We have sine and cos function. This is the previous one. This is our general equation. So we know that after we do some calculation in general, so if the cos, sometimes they will give a 0 value, so we will eliminate the an coefficient, and then sometimes we will, for the even we just only have this, because even this will be 0. For the odd function, cos will be 0. Cos will be 0. So you just remember 1, so it's more easier to. And then the other one is reverse to your concept. So for your even, okay, for the even, so as you can see here, if the even function, so they will only have a cosine term. So we should have b and cos sine here, but once we calculate, there will be a zero result. So that's why we just can eliminate the sine function. So okay, from here, if we identify this the graph, once we plot the graph, determine the type of function, and then give your reason why you said there is even, why you said the odd function. So there is 3 reasons that you can give. You do the function, you put the function negative x inside the fx, and then you sketch the graph. You find that it's symmetrical by y or symmetrical by the original, and then for that there is from the y, so symmetrical y, so there is even. So that's why you call it as a even function, because of this. So you need this argument for your statement that you said that even or odd. Okay, and then you find the coefficient. So once you find coefficient, since you know that it's even, so you just deal with the sine, cos. So even just cos, deal with the cos, an inside in front. But if you, the thing is more similar, just double of this formula. We put 2 instead, and then we put from 0 to L. That is our the main idea of this formula. And then as usual, we need to integrate first, take this, and then put the finite numbers here, that the range of our function, and then we simplify, get with this, then the Fourier coefficient, we get this. Okay, and then there is another example. So there is even function, and then there is for the odd function. We just deal with the coefficient of bn, which is we deal with the sign. Okay, we deal with the sign. So from here we can move like this. We calculate two times. Just double it the area, because we know that it's asymmetrical. So we just deal with the sine this, and for the Fourier coefficient we just this fx. Okay, first of all we sketch the graph, and then we said that it's odd because there is symmetrical about the original. Symmetrical about the original meaning, okay, we put the mirror here. Okay, the mirror here. Okay, we put the mirror here, so this will be like this, and then we have another this one. We put the mirror here. Okay, the mirror here. So we have this function, this and this. So this become this first mirror become this, and then we put another mirror in the here, the x-axis. This another mirror. This become this. Sorry, this become this. We need to delete this. Okay, this become this. So this become this. This become this. That's why we call it a symmetrical about the original. Okay, so now we calculate the b. We just deal with the sign, put the infinite number here, finite number here, and then we get the Fourier series more faster lah, instead of we do the previous the original one. There is another example that you can see and do it yourself. Just close this answer, and then try to write back from your what is it you understand from this example. Okay, that's all for the Fourier series. So we end the lecture for the Fourier series. Thank you for your attention. If you have any question, please ask with the support group, or just personally message me, okay? Or you can ask in our lecture face to face next week. Thank you.